Hey everyone, and welcome. Today we're going to dive into one of the biggest ideas in all of Java, inheritance. And to get our heads around it, we're going to use something you're probably holding right now. Yep, your smartphone. Let's jump in.
I mean, this quote just nails it, right? You never, ever start from scratch. You take a solid foundation, something that already works, and you build on top of it. That's the whole game. Starting with a base model and adding your own cool features, that is literally what inheritance is in Java. It's all about not reinventing the wheel.
Okay, so think about it like this. You've got your base model phone, right? It's got the OS, the basic apps, all the settings, the essentials. Now, when the company makes the new model, they don't start over. No way. It automatically gets all of that stuff from the base model. It inherits it. But then it adds the cool new stuff, that amazing camera, the super fast charging. You see, it takes a great foundation and just makes it better. That's the big idea.
So here's the game plan for today. We're going to start with the big idea, then we'll jump right into the code to see how it actually works. After that, we'll look at how you can customize things, cover the must-know rules, and wrap it all up with a slick, modern Java 21 example. Sound good?
All right, let's kick things off. Section 1, the big idea. And the theme here is so simple but so powerful. Just build on what already exists. Okay, so let's get the official definition out of the way. Inheritance is basically a mechanism in Java where one class, let's call it the child, gets all the good stuff, the properties and behaviors from another class, the parent. Here's another way to think about it. Imagine a huge restaurant chain. When they open a new branch, that new place automatically gets the whole menu, the recipes, the way they run the kitchen, all of it. But that new branch can totally add a few local specials to the menu. It is a version of the main restaurant, just a little different. So why bother with all this? Oh, the payoff is huge. First off, you stop repeating yourself. No more writing the same code again and again. That alone keeps your whole project cleaner. It lets you build massive, complex systems way more easily because you're modeling how things actually work in the real world. Seriously, think of inheritance as your master blueprint. Once you have it, building everything else is just faster, easier, and a whole lot more reliable. Okay, so we've got the why down. Now for the fun part, the how. Let's get into section 2 and look at some real code. We're going to focus on two key words that make all of this possible: extends and super. Honestly, it all kicks off with this one little keyword, extends. That's the magic word. The second you see a class that extends another one, you know exactly what's going on. It's a child class, and it's inheriting from a parent. That single word is what forges the entire connection.
Take this for example. A car, well, it's just a more specific kind of vehicle, right? So when we write class car extends vehicle, we're telling Java about this is-a relationship. A car is a vehicle. And boom, just like that, our car class gets all the public stuff from vehicle for free. We didn't have to write any extra code for it, it just happens.
So here's that blueprint we were talking about, the vehicle class. Super simple. It's got a property, speed, and a behavior, a start method. So any class that comes along and extends vehicle, like our car, automatically knows about speed and can use that start method. It's part of the package now.
Okay, but what if the child needs to, talk back to its parent? That's where our next keyword comes in, super. Let's go back to that restaurant. A customer asked the waiter about a big company-wide discount. The waiter might have to go, let me check with my manager. In Java, when a child class uses super, it's basically checking in with its manager, the parent class.
And check this out. See that line super.start? That is the car class saying, hey, I want to use the start method from my parent, vehicle. It's the direct line for a child to tap into and reuse the code it just inherited.
So inheriting stuff is great, super powerful. But what if you don't like what you inherited? What if you want to change it? Well, that's where the real magic happens. Let's get into section 3 and talk about making it your own with something called method overriding.
Method overriding is, it's pretty much exactly what it sounds like. The child class looks at a method it got from its parent and basically says, you know what, thanks, but I got this. I'm going to do it my way. It keeps the exact same method name, but it swaps out the guts for its own unique code. Think about a delivery app. Every single vehicle in that app needs a getRoute method. But you can't give a bicycle the same route as a car, right? The bicycle needs bike paths. The motorcycle has to avoid highways. And the car wants the fastest roads possible. See? It's the same method name, getRoute, but the behavior is totally different and specialized for each one.
That is overriding in a nutshell.
And here's how it looks in the code. Our parent vehicle class had a totally generic start method. But the car class, it overrides it. And you see that @override thing? That's not just for show. It's you telling the compiler, hey, just so you know, I am intentionally overriding a method from my parent. It's a great safety check. And now, when you start a car, you don't get the generic message. You get car starting with keyless ignition, its very own specific behavior.
Okay, on to section 4. Think of this as the rules of the road, the fine print. This is all about what you can, and just as importantly, can't, access from the parent class.
So, these access modifiers, they're basically the bouncers at the club. Public, the door is wide open, anyone can get in. Protected is like the family and friends list. Child classes can get in even if they live in a different neighborhood or package. Default is for locals only, just for classes in the same package. But private, that's the VIP room. Those are the parents' secrets. Nobody gets in, they are not inherited.
So just to be super clear, here's what you don't get. You don't get the parent's constructors, you definitely don't get his private stuff, and if a method or even a whole class is marked as final, forget about it. You can't touch it, it's a dead end. This is actually a big deal, and it's why developers are careful not to create these gigantic, sprawling family trees of classes. They can get complicated.
All right, time to bring it all home. For our last section, let's see some modern Java in action. We're going to look at a full, clean example using some cool features from Java 21.
And right away, we see something new, the sealed keyword. This is a pretty modern feature in Java. Think of it like this. The vehicle class is setting up an exclusive club. It's putting a list on the door that says only car and bike are allowed in, nobody else. It gives the parent total control over who is allowed to inherit from it. Super useful. And here are the 2 members of our exclusive club. Both car and bike extend vehicle, just like they were told, but look closer. Each one brings its own flavor to the start method. The car has a fancy push-button start. The bike has a good old-fashioned kickstart. So they share that vehicle DNA, but they absolutely keep their own unique personalities.
And here's the grand finale, putting it all to use. We make a new car object and call it special start method. But wait, we can also call open sunroof, a method that only a car has. Then we make a bike and call its start method. This right here, this is the whole point. We have different objects, they share a common ancestor, but each one behaves exactly the way it's supposed to.
So, at the end of the day, inheritance is all about reuse, organization, and being able to scale up your code. You build on what works, and then you specialize. But this brings up a really interesting question, doesn't it? We know a car is a vehicle, and a bike is a vehicle. They both have a start function. So, how does Java know which one to run? That, my friends, is a question we'll answer next time, when we jump into the amazing world of polymorphism.